Dr. Pia is a research fellow in astrophysics at the University of St. Andrews. Her research revolves around extrasolar planetary science. She's interested in exoplanets data science applied to astronomy and projects related to women in science. Thank you so much for being here today.
No, thank you for inviting me.
So, first of all, what was the motivation for you to pursue a career in astrophysics? When did you know that this is what you wanted to do for a living?
I think my main motivation was first that when I was at school, I was good at math and physics. So I was in an only girls Catholic school in Chile. So, well, 20 years ago, we were more motivated to follow careers related to, I don't know, law, for example, or medicine, but not research careers. So I was like, no, I want to do something different. I am good at math and physics. So, okay, at some point I was like, I want to do research. In what? I don't know, but I want to do research. And I want to be a scientist. That was my first decision. And well, I grew up in La Serena, which is a city in Chile with a lot of observatories because it's one of the best places in the world to do astronomy. So I knew that there was this career called astronomy and you could do research about it. And yeah, I started investigating probably similar what like you are doing, you know, reading a lot, trying to know what is to be an astronomer. And yeah, I think my main motivation was that I wanted to do something different, that motivated me to discover things, you know. During high school, you know, when you are starting to think about the decision that you need to do in a few years, so around 15, 16 years old, I think that's when I decided to be a scientist.
It's so nice to hear that you wanted to do something unique, something different from the traditional career fields. And it's also so nice you had so much exposure living in your city with observatories around. That's really nice to hear. So,
Yeah, and you know, one thing that I was surrounded by observatories, but I didn't actually meet an astronomer. We knew, you know, that in the city there were astronomers there living and working there, but I never actually meet an astronomer living there. So it was kind of, you know, not so good in that part.
you got your master's and bachelor's degree in Chile, your PhD in France, and you're currently working in Scotland. So, what have your experiences been working in different countries, and how do you think it has influenced your journey?
Well, I think that at some point when I started studying astronomy, I realized that you can't do your career in one country. I mean, in some specific cases, maybe you can. For example, in the US, I know colleagues from the US that they haven't moved in their whole career, you know, because you have a lot of good universities and it's not really a need to move. When you are from a developing country with not a lot of funding in science, you know, and you realize very early in your career that you need to move. That it's not that easy to do a career in just one country. So probably Chile is one of the best places to study astronomy because you have the observatories there. But there is not a lot of funding from the government to do science. So yes, you have the observatories, but you don't have the money to do research. So at some point, probably at the end of my bachelor's, I decided that I wanted to do my PhD in another country, in Europe mostly. So how that affected my career? Well, it opened the doors, you know, it opened the the opportunities that I had, because you don't have this in other countries, not in Latin America in particular. So doing my PhD in France, for example, gave me the opportunity to collaborate with people from Canada, from the US, from the UK. I started being part of big collaborations, and at the end, for example, it gave me the opportunity to do this postdoc in Scotland because we were working in similar projects. You met the people that you probably are never going to meet if you stay in Latin America, for example.
I think the funding thing is also something that happens in India because there's such limitation of funds that are given for scientific research that many researchers end up leaving India and then going and settling in different countries because it depends on how much support you get in your country to follow your passion.
Yeah, I mean, yeah, and in Chile, it's really strange that, for example, sometimes my colleagues that are using observatories in Chile, it's not my case, but it's very common that you have colleagues working with observatories in Chile. They have to go very often to Chile. You know, this kind of job, it could have been done by a Chilean astronomer. But since there is no really funding, you have to pay to do the observations. It's not for free. The money is outside, and you basically European astronomers, American astronomers, they pay to go to Chile to do the observations. So it's kind of strange, you know, this that you have the observatories there, and since there is no really a lot of support from the government to do science, other countries basically use our places or observatories.
So you're the founder of the Cazadoras, the Estrellas project, which was also shortlisted in the Nature Innovating Science Award. So can you tell us a bit more about this project and your learnings from the experience?
Yeah, sure. So Cazadoras de Estrellas started when I was doing my master's. I was very lucky that I made really good friends when I was doing my master's, fellow astronomers that we were sharing the office, we were studying together, and we realized that there were not projects related to motivating women to do science in Chile, not at the level of high school girls. So we were all like, you know, we need to do this. It's something that we would like to have when we were 15 years old. So we decided to create this project. And the idea is to travel around Chile doing this 2-day workshop for girls interested in science. It's not only astronomy, it's mostly dedicated to astronomy because we are all astronomers, but it's the global idea is to motivate them to be scientists, you know, to see the career of being a scientist as an option. Because that's the thing, we don't want to have 100 new astronomers. What we want is to give them the option to think about it, to think, oh yeah, maybe it's a good career for me, or maybe not, and I want to do something else. But to have the option to see it as a career. So we have learned a lot because we have already a few years making this project. And you see, for example, Chile is a very long country, and you have very different social behaviors between the cities in the extreme north or in the extreme south of Chile. And you see that in the girls. For example, the girls in the south of Chile, they don't really know what is happening in the north. the observatories are mostly built in the north of Chile. So the girls from the south, they have never seen an observatory in their lives. I mean, they don't even know what is to be an astronomer because they are really far away from these kind of places. And they have other worries in their life, you know, related to where they live, that is in the very, very south of Chile. So that has been something that we learn in the process. Also how, for example, schools deal with showing the girls that they have other options, not so traditional. Some schools are more motivated, for example, to have these kind of workshops. Others are not really interested, which is really sad. So it has been a lot of learning, but a lot of happiness too. It makes me really happy, this project.
Such a nice project that you're exposing more girls to careers in STEM, that they have more options available that when you were growing up, you did not know that those options existed. And it's really nice project. So
yeah, it's not something that we had, you know, when we were 15 years old.
So what do you think makes a scientist a good scientist?
Oof, that's a good question. And I think that if you ask a random person in the street, probably they would say that you have to be a genius. And that's a lie. You don't have to be a genius. I don't consider myself someone that is a genius. I mean, I do stupid things all day, every day, you know. I think that the most important thing is that you have to be a really hardworking person, because you will fail. We all fail in this career. You will get rejected a lot of times. You won't get, for example, funding for your project. Your publications could be rejected too. And it doesn't make you a bad scientist, because we all have that. There is no scientist in the world, probably a few, I don't know, Einstein. But most of the scientists right now in the world, we have been rejected once in our careers. In any other way, you didn't get the funding, you didn't get the position that you wanted, you didn't get the fellowship that you wanted, and that's completely normal. And we need to, you know, accept that we are good in what we do, but it doesn't mean that you will get everything that you apply for or that you ask for in your career. So one of the most important things that you have to learn very early in your career is that you have to be hardworking, accept failures, and also I would say that you need to be proactive, in the sense that all the options won't appear magically in front of you because you are good at something, you know? I think that if I am where I am right now, it's because I asked a lot. I tried to meet the right people. I looked for opportunities, and I did that my whole career. If you are proactive and you look for opportunities by your own, I think that that's one of the most important features or characteristics that a scientist need to have. It's not being a genius or really good at math. You have to be hardworking, proactive, and accept the failures. I think that's the recipe.
That's such good advice, because as you rightly said, normally people think that it's about you having the brains to succeed in such a field like this. But there are so many other skills that you need to master at to be successful at the end. It's just not one criteria that you need to meet. I think that's something very
Exactly.
important to realize.
Yeah, exactly. I think that we have this idea that you have to be really good in school, have the highest grades your whole life. And, it's not true. It's not totally true. I failed courses during university, and that's not the end of the world. You can fail. The important thing is that you learn from it, you recover, and you try again. Of course, there are limits. If you are trying and trying and trying and trying and you are having a really bad time with it, probably it would be good to consider another option. But if you fail once, it doesn't mean anything. You keep trying until you stop having fun. I think it's not, you can't have this forever of failing, but yeah, a few times it's fine. We all fail.
Yes, definitely. So, what do you think are the key differences between studying astrophysics through observations and theoretical modeling? And how do you think that these two approaches complement each other in your research?
I would say, and this is a very personal opinion, that the observational astronomy is like the funny part. I'm a very observational astronomer. I go a lot to observatories, and it's really fun. You are basically, you see in real time what you are observing. You are getting the data in real time. You know what you are observing, and that's really fun. Go to observatories is really fun. I really like it. But that's my personal opinion. Probably the theoretical astronomers will say the other things. But for example, if you like more to work with equations, with math, to think more in the physical problems, I would say that, okay, maybe being a theoretical astronomer, it's your path. But if people are interested in going to the observatories, for example, in learning how the instruments work, how you can make them better, and the process of analyzing your data, how you can improve the data analysis, I would suggest to follow the observational astronomy part. How we complement? Well, it's a thing that we do every day. For example, I am studying active stars, and I need to know the physics behind the active stars. I need to understand how they work, and to do so, there are equations that I need to understand. And those equations were formulated by theoretical astronomers. So one type of astronomy cannot survive without the other. We really need both types of astronomy, if you want to say it like that. But it's really a very personal opinion in which you think it's more of your like, for example. But both can study interesting parts of and problems of astronomy.
It's true. It's that you cannot do one thing without doing the other. They're both interdependent.
Yeah.
How do you think high school students can start contributing to scientific research and learn more about astrophysics?
I could give you a few ideas. For example, when I was in high school, we had something called the planetarium. It's very standard. You have planetariums in most of the big cities. But what we used to do is that when you were in your last year of high school, it was your year where you have to prepare this planetarium for the school. So it was really funny because every year you have like a new version of this planetarium, and each new level had a different approach. You could dedicate your planetarium to, I don't know, solar system. And the next year, the final level of the high school decided to, I don't know, dedicate the planetarium to the observatories in Chile. And you have different topics every year. You have different expositions and things. So if you are interested, I would suggest to prepare, for example, a planetarium for your high school. Other thing is that, for example, if you are really interested, and it's something that I did when I was in high school, do what you are doing right now. I mean, you don't need to do a YouTube channel, for example, but if someone is really interested in know what is to be a scientist, you can just send an email, to someone. I did that when I was in high school. I knew that there was an astronomer a few years ago that she was in my high school too. So one of my teachers told me, oh, this girl was a student here and now she's an astronomer in the US. So you could try to contact her. And I did, and I sent her an email. She replied, she was really nice, and she gave me some advice. So that's something really simple that you could do if you really have very specific questions about the career, and you can contact someone, do it. I mean, everything is in Google. It's not that difficult. You can find emails addresses, you can find information about astronomers or scientists in general, and just send an email and ask questions. The worst thing is that probably, I mean, one option is that you never get an answer, but I think that's really low probability. I mean, most of the scientists, I think we would be really happy to just answer an email about questions, from a high school student. That's the kind of things that you could do if you are interested in following a career in science.
That's really good advice. And I feel a lot of students are scared to ask questions, but because there's this thing that they're such a professional, why will they want to respond to us? But it's you making an active effort to just try and give it a shot, because people are always ready to help.
Yeah, and of course, probably we won't reply immediately or in one day because we are really busy working. But at some point, if you give us time, or even if after a few weeks we don't reply, just ask again. It's not bad to. I think we come back to being proactive. If you don't get a reply, don't ask the next day, but you can ask again in a few weeks. Like, oh, okay, I sent you this email. Probably it's in your, I don't know, spam. Could you, check it? Thank you. So don't be afraid to ask. It's one of the basic things that we do as scientists. We ask a lot of things.
Yes. Finally, what do you think is the best part of being an astronomer?
Ooh, there are a lot of good parts. One thing is that you meet people from all over the world, like literally from all over the world. Like your view of the world expands a lot. Like there are a lot of, we all have biases in our mind, unconscious biases. When you meet people from different cultures, from different religions, from different countries, slowly you start detecting your own biases, and you can work on that. And that's something that if you have a normal career, for example, not in science, it's more difficult. So one good thing that astronomy has given me, it's to have a lot of friends from all over the world. The second thing I would say is that you travel a lot too. You have the option of living in different countries, probably easier than following a traditional career. Other good thing I'm thinking, like the problems that you solve at some point, you realize that you are one of the few people in the world that you are working on that. And for example, well, in my case that I'm discovering exoplanets, probably right now I am the only one working in this particular discovery. So it's like, if you put it in context, it's like, wow, I mean, I'm the only one right now that knows that there is this exoplanet around this star. I mean, yeah, it's a random star, it's nothing special, but it's information that you only have, you know, it's really, it's a strange feeling, but it motivates me to keep doing this because it's easy to lose the motivation because sometimes problems are really hard. You spend a lot of days trying to do something and it's not working, and so it's easy to, you know, not to have a lot of motivation every day. But when you put it into context, you are like, oh yeah, this is really cool. I keep trying and you will find a solution. But I mean, it's really cool. So there are a lot of things, good things of being an astronomer. Visiting the observatories, that's really cool. Like when you are in an observatory, you are basically in a hotel, you know, at the top of a mountain. You have free food, a lot of food. In some observatories in Chile, they are famous because they have ice cream machines. So you can have ice cream whenever you want. It's basically staying in a hotel at the top of a mountain doing observations. You know, that's extremely cool. That I would say that's the highlights of being an astronomer. Yeah.
It's like a never-ending list. There are so many things that draw you into this career.
Yeah, I think that's the most important thing. If you can keep your motivation high, keep doing it. But of course, there are not all the things, you know, are good. There is a lot of, well, for example, being a woman in science is not always good. You don't always have good experiences. But in general, I think that the experience tends to be more good than bad. But I know that that's not always the case. So we need to be careful. Yeah, it's a really amazing career. You have a lot of good things, but there are still a lot of changes in the process of being a minority in science, of being a woman in science. But there is a lot of things that still need to change that for we all have the same good experience.
True. There are some issues that obviously end up hindering your progress, end up affecting how much you love the thing. But then there's also that motivation for you to keep going because you love it just so much.
Yeah, that's true.
So thank you so much, Dr. Pia, for sharing your experiences. It was really nice to hear your different perspectives on things, and I truly learned a lot from them. And I hope my audience did too.